Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. So now we are starting next part of this chapter. So let us begin with the quantifiers. There are two types of quantifiers. One is universal quantifier and second one is existential quantifier. So this universal quantifier is denoted by this notation, and this notation is read as for every or for all. So simple thing is there, for every or for all is denoted by this notation, and this notation is called as what? Universal quantifier. Second quantifier is existential quantifier. Existential quantifier is denoted by this notation and it is read as there exist. So two types of quantifiers are there. One is universal, second one is existential. Universal quantifier is denoted by this notation and read as for every or for all, and this is existential quantifier which is read as what? There exist. Now second part of this quantifier is quantified statement. An open sentence. Open sentence means what? Both possibilities are there. May be possible that it is true or may be possible that it is false. Means truth value varies. In such sentence, if we are using quantifier and using quantifier, if that open sentence become a statement, then that statement is called as quantified statement. Or simply in a statement, if quantifier appears, at that time it is called as what? Quantified statement. Just try to understand the example of quantified statement. If I am saying that x plus 5u is equals to 7 for x belongs to natural number. Now exact value of x is not given to us. It is given to us that x is natural number. Now which are the natural number? 1, 2, 3, 4, 5, 6, continuing this way. These are what? Natural number. Now this condition is satisfying for which natural number? If I am substituting x is equal to 2, 2 plus 5 is equal to 7. Means for x is equals to 2, this statement is true. And for other natural number, say 3, 4, 5, 6, this condition is not satisfying. So means for some natural number it is true. Means for x is equal to 2 it is true, and for x is other than 2 it is false, isn't it? Means truth values are varying, and if truth values are varying, at that time it is called as what? Open sentence. In this open sentence, now if we are using quantifier, so let us use the quantifier existential quantifier. So we can say that there exists x belongs to n. There exists x belongs to n such that x plus 5 is equal to 7. There exists x belongs to means there exists at least one natural number. There exists at least one value of x in this natural number where this condition is satisfying. Check that is there exists some natural number? Yes, there exists a natural number 2, where 2 plus 5 is equal to what? 7. Means they are saying that there exists at least one value of x in natural number which satisfies this condition. Yes, there exists one natural number 2 which satisfies this condition. So we can say that it is a true statement. And since we are able to identify it is true or false, we can say that it is what? Statement. So using quantifier, this open sentence become a statement. So we can say that it is what? Quantified statement. If I am using for every x belongs to n, x plus 5 is equal to 7. Is it possible that for every x, second quantifier is what? Universal, which is read as what? For every. So for every x belongs to natural number, means for every natural number this condition is satisfying. So definitely not. So for 1 it is not true, means for some natural number it is true, but for every natural number x plus 5 is 7, it is not possible. So it is false. It becomes what? False. What they are saying that for every natural number, for every x belongs to n, means for every value of x in natural number, means every natural number satisfies this condition, which is not true. So that's why we can say that it is false statement. So using quantifier, we have converted open sentence into what? Into a statement. Why we are saying that it is statement? Because here we are able to identify its truth value. In the first case this will become true, and in the second case it will becomes what? False. So using quantifier, open sentence becomes a statement. Such statement is called as what? Quantified statement. Or simply you have to remember that in a statement quantifier appears, at that time it is called as what? Quantified statement. Now we are discussing how to find out the dual of compound statement. So see, some very simple rules are there to find out dual of the compound statement. If some compound statements are given to us, to find out dual, just simply use this rule. Replace and by or by and, or by and, capital T by capital F. Capital T means true. Replace true by capital F means by false. In the same way, replace capital F by T. Replace small t by small c. Small t means tautology, small c means contradiction, and small c by small t. If we are using these rules in the given compound statement, means in short we are finding dual of that compound statement. So let us consider here some example. So we have written some statement and we are trying to find out its dual statement. So let us try to find out its dual statement. So don't disturb to later, only observe that whether these terms appears in the statement or not. So if and appears, replace it by what? Or. So in this way we are finding dual of this compound statement, dual of the statement. Now here negation P, keep it as it is. According to our rule, or will get replaced by what? And. Replace this or by and. Now in the third case, capital T will get replaced by what? Capital F. So replace it by capital F. Again or will get replaced by and, keep Q as it is. So hope the idea about how to find out the dual is clear. If this notation appears in the statement, then replace it by this notation. So new statement is called as dual of the given statement. So in this case we are not disturbing to P, and will get replaced by or. Q, keep it as it is, or will get replaced by and small c is not a statement. So small c is used for what? Contradiction, and small c will get replaced by what? Small t. In this way, using these rules we are able to find out dual of the compound statement. Now let us see how to find out negation of the compound statement. So simple rules are there whenever we are finding negation of the compound statement. So first condition is replace every letter by its negation. Replacing every letter by its what? Negation. Second rule is replace and by or, and third rule is replace or by and. Using these rules of negation we are able to find out negation of the compound statement. So first we are finding negation of negation. So negation of negation means negation of negation P is equivalent to. Now let us suppose that P is one statement. Then how many possibilities of truth value are there? Either it is true or either it is false. Let us try to find out its negation. What is negation of true? False. Negation of false is what? True. Now we are finding negation of negation P. Already truth value of negation P is known to us. Again we are finding negation of this statement. What is negation of false? True. Negation of true is false. Here we can observe that truth value of P and truth value of negation P are identical, TF. And we know that if truth value of two statements are identical, at that time two statements are logically equivalent. Means negation of negation P is equivalent to what? P. Means this result says that negation will get cancelled, and what result we are getting? P. In this way we have seen how to find out negation of first logical connective, negation. Now we are finding negation of conjunction. Conjunction means what? And. If two statements are connected by which logical connective? And we are finding negation of this statement. Again now we are applying these rules of negation. These rules of negation says that replace every letter. How many letters are there in this bracket? 2 letters. Replace every letter by its negation, and will get replaced by what? Or. So replace first letter by its negation. This or will get replaced by or, and replace second letter also by its negation. So using rules of negation we have seen how to find out negation of what? Conjunction. Using same rule now we are finding negation of disjunction. Disjunction means what? Two statements are connected by or, and we are finding negation of this statement. What we have seen in case of negation, so our rule says that replace every letter by its negation. Two letters are there, we have to replace both the letter by its negation, and or will get replaced by and. Means what result we will get here? Negation P, or will get replaced by and second letter also get replaced by its negation. So these two results are called as what? De Morgan's law. In the next video we are going to prepare one table in which we will note down all these results also. Now we are finding negation of implication. So if two statements are connected by implication, implication is used for which logical connective? Means it is symbolical representation of which logical connective? If then. So means in short we are finding negation of statement which is connected by if then, isn't it? Now here in our rule there is no rule for what? Implication. So in such cases, see what we have to do here. So we have proved that P implies Q is equivalent to what? Negation P or Q. We have proved this result when we have discussed the definition of equivalent statement. In that case we have constructed the truth table of both the statement, and we have observed that truth value of both the statement are exactly same, which is called as conditional law. So if you want to check whether these two statements are equivalent or not, just simply construct the truth table and check whether these two statements are equivalent or not. Okay, so now we are finding negation of what? P implies Q, so which is equivalent. We are not disturbing to negation, just simply we are replacing P implies Q by its value negation P or Q, because P implies Q is equivalent to negation P or Q. Now we are able to apply our rules of negation. So negation of negation P, just now we have seen that negation of negation P is P. Now negation of or will get replaced by what? And replace last letter Q by its negation according to our rules of negation. Replace every letter by its negation or by what? And. So first letter is what? Negation P. So negation of negation P is P, or will get converted into and lastly what will get? Negation Q. Means what we have seen that here P and negation Q will be the negation of what? P implies Q. Now suppose that one statement is there, if x is even, then it is divisible by 2. If one statement is there which is the first part x is even and second part is it is divisible by 2, means x is divisible by 2. If we want to find out negation, so you have to use this result. P means what? X is even, and Q means what here? X is divisible by 2. Now convert this symbolical representation into verbal form. P means what? X is even and it is not divisible by 2, and it is not divisible by 2 will be the negation of this statement. Means don't use not in this statement. Using this symbolical representation or using this result, try to find out negation of what? Implication. Implication means if two statements are connected by what? If then. At that time we have to use this result while finding negation. This is your P and this is what? Q. So just substitute P here and Q here in this symbolic form to find out negation of implication. If we are substituting this value, what we'll get? X is even and can be written as but. X is even but it is not divisible by 2. Use negation in Q. It is not divisible by 2 will be the negation of this statement. Means while finding negation of compound statement, we have to use these rules of negation. Lastly, let us discuss negation of double implication. Now if two statements are connected by double implication is used for what? If and only if, and if we are finding its negation, so try to understand how to find out its negation. P if and only if Q can be written as P implies Q and Q implies P. Here we can observe that P implies to Q also and Q also implies to P. Now we have to find out its negation. Negation of P if and only if Q. Means in short we have to find out negation of P implies Q and Q implies P. Let us try to find out its negation. According to our rules of negation, what our rule says, replace every letter by its negation, and by or, and or by and. So consider this as first letter, this as second letter. So replace this first letter by its negation, means negation of P implies Q, or will get replaced by and will get replaced by or, and negation of second letter means here Q implies P. So we have replaced first letter also by its negation, second letter also by its negation, and by or. Just now we have seen that what is negation of P implies Q? P and negation Q. So here negation of P implies Q means P and negation Q. Keep this or as it is. Now we are finding negation of Q implies P, means here P implies Q will get replaced by what? Q implies P, means in short we are interchanging these two letters. P is replaced by Q and Q is replaced by what? P. So on this side also replace P by Q and Q by P to find out negation of Q implies P, means what result we will get here? Q and negation P. Hope you have got it. Just here P and Q are interchanged by means P is replaced by Q and Q is replaced by P. So on this side also replace P by Q and Q by P to find out negation of Q implies P. Now you have to remember this result, that negation of P if and only if Q is P and negation Q or Q and negation P. So this result we have to use while finding negation of the compound statement. If suppose that two statements are there, X is even number, if and only if in short can be denoted by this notation. If these two parts are connected by if and only if, then see what is the first part? X is even. If and only if X is divisible by 2, means these two parts are connected by if and only if. And to find out negation of this statement we have to use this symbolical representation. तो आपको ये symbolical representation learn होने चाहिए. So now in this symbolical representation substitute the value of P and Q. What is P? X is even. What is Q? X is divisible by 2. So here X is even but it is not divisible by 2, or X is divisible by 2 and it is not even. Just I am replacing P by X is even and Q by X is divisible by 2. P means X is even and can be read as but it is not divisible by 2, or X is divisible by 2 but it is not even. This will be the negation of this statement. Don't use not in this statement directly. Use these rules of negation to find out negation of this compound statement. Lastly, remember this result. If some statements start with for every or for all, or this is symbolical representation of what? For every, which is called as universal quantifier. And if we are finding negation of such statement, at that time the new statement will get start with what? There exists, or by some, or in case of universal quantifier, if universal quantifier for every is there, then replace it by there exists. Same method is used if this statement start with some or there or for every, then to find some or there exists, then to find out its negation we have to use what? For every or for all. So using all these rules we have to solve the example. Let us consider here one example. Suppose that one statement is there, all students of class 12th are boys. All students of class 12th are boys. So here all is used. So its negation will become what? There exists at least one student in class 12th which is not a boy. If we are using some, at that time we can say that some student in class 12th are not boy. Isn't it? Don't write in this way, all students of class 12th are boys, so all students of class 12th are not boys. This is wrong. So don't use all will get replaced by there exists or by what? Some. So these are all rules of negation which we have to apply while solving the examples. Now let us discuss how to find out converse, inverse and contrapositive of the given conditional statement. Conditional statement means if two parts of the statement are connected by which logical connective? If then. Means conditional statement is also called as what? Implication. So here if P implies Q is the conditional statement, then we are discussing how to find out its converse. Converse, already you are very well aware with this word, because in geometry you have proved some theorem and converse of that theorem. What in that case, what we have seen, if P implies Q, then Q implies P will be its converse. Just take an example. If triangle is isosceles, means if two sides of a triangle are equal, then angle opposite to them are equal. Means sides are equal, then angle opposite to them are equal. And its converse part, if two angles of a triangle are equal, then side opposite to them are equal. Means P implies Q, its converse is what? Q implies P. In the 10th standard you have proved BPT and converse of BPT. Means if P implies Q is the given statement, means first part is given, we have to prove the second. And if second part is given and we have to prove the first, that is called as its converse, isn't it? Now if statement is, if triangle is equilateral, then it is equiangular. Which is the first part? Triangle is equilateral. Let us denote it by P, and the part after then denoted by Q. So its symbolical representation is what? P implies Q. So part after P is denoted by the part after if denoted by P, and after then denoted by Q, isn't it? So what is P here? Triangle is equilateral. What is Q here? Triangle is equiangular. Now we are finding its converse, means first write down Q, then write down P. But implication is there, means start with if triangle is equiangular, then it is equilateral. It will become what? Its converse, isn't it? Now its inverse. Inverse means what? Negation P implies negation Q. So whatever may be the first part is there, use negation in the first part as well as use negation in the second part. Whatever may be the given statement is there, in the first part also we have to use not, and in the second part also we have to use not. The new statement which you are getting, it's called as what? Inverse of this statement. So see what we'll get here. If triangle is not equilateral, then it is not equiangular. Just simply we are using not in both the parts. Is it clear? The new statement, the triangle is not equilateral. If triangle is not equilateral, then it is not equiangular, will be inverse. Now contrapositive. Contrapositive means what? Negation Q implies negation P. Negation Q implies negation P. Means we have to write down negation in this statement also and negation in this statement also. But start with what? Negation Q. So here this is Q, and since implication is there, so we have to start the statement with if, and second part is after then. So if triangle is not equiangular, then it is not equilateral. This will be what? Contrapositive of this statement. Simply you have to remember this symbolical representation while finding converse, inverse and contrapositive. From the given statement you will get P and Q, and just simply convert this symbolical representation in verbal form to find out converse, inverse and contrapositive. So in this way we have completed theoretical part essential for next exercise. In the next video we will start the examples from next exercise.